Your engine wears a Toyota, Honda, or Hyundai badge, and somewhere in the back of your head, you filed that away as a decision you'd never have to think about again. For about 30 years, that was a reasonable place to file it. Then the recall letters started landing, and they weren't about airbags or wiring or a sticky throttle pedal. They were about bearings, crankshaft bearings. The parts nobody outside a machine shop ever thinks about, in engines from the three companies that built their entire reputation on never making you think about them. Here's what almost every explanation of this gets wrong. The story you've been told is that these companies got sloppy, that quality control collapsed, that somebody stopped caring. That's not what happened. The metal shavings killing these engines have been in engines since engines existed. There has always been swarf in the block. There has always been a burr left in an oil passage. What changed isn't the dirt. What changed is that the engine can no longer survive the dirt. And it can't survive it because of decisions made a decade earlier in a boardroom that had nothing to do with the factory floor. I've had enough of these apart to know what the bottom of the pan looks like when it's gone wrong. That dull gray glitter in the drain oil that means you're not fixing anything today. So when three separate manufacturers with three separate engine architectures start killing bearings in three separate ways, I stop looking at the factories and start looking at what all three were being asked to do. By the end of this, you'll understand exactly why a particle you couldn't see on your fingertip can kill a $15,000 engine, why it's always the same bearing on the Toyota, and what you can check on your own vehicle this weekend for the price of a filter and a coffee. And I'll tell you about a repair remedy that involved a tablet computer, a quiet parking lot, and an algorithm nobody would explain. Because once you understand what that was actually for, you'll never look at a recall notice the same way again. Let's start with the thing everything else rests on, because if you don't have this, none of the rest of it lands. A crankshaft does not touch the engine. That sounds like nonsense, but it's the whole trick. The crank spins inside soft shell bearings, and between the spinning steel and the soft shell, there is a wedge of pressurized oil, and the crank rides on that wedge the way a hydroplaning tire rides on water. Metal never contacts metal. Not at idle, not at redline, not at 200,000 miles. The bearing isn't a wear part the way a brake pad is a wear part. In a healthy engine, it theoretically never wears at all, because nothing ever touches it. How thick is that wedge? Thinner than you'd believe. The hydrodynamic film under load runs on the order of 60 millionths of an inch. For scale, a human hair is 3 to 4 thousandths thick, and the smallest thing your fingertips can feel is around half a thousandth. So the film holding your crankshaft up is somewhere around a 50th the thickness of a hair, and the pressure inside it can easily exceed 50,000 psi. That is the load being carried by something you'd struggle to measure. Think about a puddle on a hot road in July. Drive over it fast, and the water holds you up and you never touch asphalt. Slow down, the film collapses, and the tire grabs. That's a bearing. Speed and viscosity build the wedge. Load tries to squeeze it out. Now drop a grain of sand into the puddle. Doesn't matter at speed. But when that film gets to its thinnest, under load, under heat, at low RPM, pulling a trailer up a grade, a particle taller than the film is no longer floating in the oil. It's a chisel held between two surfaces, dragged around at 40 revolutions a second. That's the mechanism. Everything else here is a variation on it. So here's the part that reframes the story. Manufacturers have known about machining debris forever. The industry wrote entire standards about it. The premise being that particles left over from manufacturing and assembly cause a substantial jump in wear during early life and may even cause catastrophic failures. So the amount introduced during the build has to be controlled and measured. Those standards arrived around the turn of the millennium precisely because damage from residual dirt was climbing. Anti-lock brake units, diesel injection systems, things sensitive enough that the smallest contamination meant malfunction, accelerated wear, or total failure. Read that again. The industry identified 25 years ago that as parts got more precise, they got less forgiving of the dirt they'd always contained, and then made every part more precise anyway. Why? Fuel economy. Not one dramatic decision. 1,000 small ones, all pointing the same direction. Engines got smaller and got turbochargers bolted to them, which raised cylinder pressures and raised the average load a bearing carries. And at the same time, automakers moved to thinner oils to cut friction. Thinner oil is where it really bites, because to support it, you have to tighten the clearance between crank and bearing. Higher loads plus thinner oil means everything has to be machined, cleaned, and assembled perfectly. The traditional number for bearing clearance is about 1,000th of an inch for every inch of journal diameter. That was never a law of physics. It was a compromise, arrived at over decades, balancing oil flow, load capacity, and this is the part that matters, how wrong things could be from the factory and still be fine. It works especially well for production tolerance parts, where there might be minor out of round or taper or measurement error. It had slack built into it. It expected the real world to be imperfect. Squeeze that clearance down to run a thinner oil, and you haven't just made the engine more efficient, you've spent the slack. You've taken the allowance that used to absorb a burr, a slightly convex journal, a fleck of swarf that got past the wash station, and converted it into about 0.5 mile per gallon. That's the real cause, not sloppiness. Margin, deliberately traded away, and then billed to you. Let me put the 3 cases next to each other, because they're the same disease showing 3 symptoms, and one of them isn't like the others in a way I find genuinely interesting. Toyota's is the loudest. The engine is the twin-turbo 3.4 V6 that replaced the old 5.7 V8 in the Tundra and the big Lexus SUVs. Toyota's own filing with regulators says that during a specific production period, machining debris of a particular size and amount may not have been cleared from the engine during manufacturing and went on to contaminate the engine assembly. And that pressure on the main bearings due to the engine configuration is such that if debris adheres to the bearings and the engine keeps operating at higher loads over time, the bearings may fail. Knocking, rough running, no start, or a stall. Owners often report no warning at all. A sudden loss of power, frequently while towing, or at altitude. Now here's the detail that separates this from a simple cleanliness story. It isn't random which bearing dies. It's the front one, every time. Toyota's teardown work found a stack-up of bearing pressure driven by timing chain tension and engine loading at the number 1 main bearing, the frontmost, closest to the chain. The front of the crank is being loaded by the chain at exactly the bearing where debris tends to land, and under heavy towing, the oil film there is squeezed hardest precisely where it can least afford contamination. I want to be honest about where the disagreement sits. Toyota has not acknowledged any design flaw and continues building this engine today. A lot of working mechanics look at a failure that only ever hits one specific bearing and call that a design characteristic, not a housekeeping accident. I lean that way myself, and I'll tell you plainly, that's my read and not a finding. The conservative position, and the one I defend in front of an engineer, is that it's a contamination defect that a tight margin layout turned from an annoyance into a catastrophe. Debris is the bullet. The layout is what made it lethal. Honda's is different, and I think it's the most instructive of the three, because there was no debris involved at all. Honda's report said improper settings of the equipment used to manufacture the crankshaft meant the crank pin was improperly ground, resulting in crank pins with a crown or convex shape that are out of specification. That's it. The rod journal came off the grinder very slightly barrel-shaped instead of dead cylindrical. Those out-of-shape journals create high-friction zones resulting in metal-on-metal contact, and Honda's language was that the connecting rod bearing can prematurely wear and seize. Sit with the scale of that error. A journal, a fraction of a thousandth proud in the middle. In a 1990s engine with generous clearance and thicker oil, that convexity gets swallowed by the film. The bearing beds in, and the engine runs to 300,000 miles and gets sold to a kid. In an engine designed around a film 60 millionths thick, the same convexity is a high spot that touches. The recall covered 248.99 vehicles across 2015 through 2019 model years, with only about 1% estimated to actually have the defect and 1,450 warranty claims for engine failures logged. Hold on to that 1%. We'll come back to it, because the whole remedy strategy is built on it. And the story didn't end there. Federal investigators opened a fresh investigation in August 2025 covering the same family of V6s in the TLX, MDX, Pilot, Odyssey, and Ridgeline, with over 400 reports of complete engine failure, and the documents state these failures were determined to be outside the scope of the earlier recall, the evidence not suggesting the same crankshaft manufacturing defect. So, rod bearings failing, same engine family, known cause ruled out. Nobody has publicly explained that one. I'm not going to invent a reason for you. It's open and it's big. The probe reaches roughly 1.4 million vehicles. Hyundai's is the oldest and the ugliest, and it shows you where this road ends if nobody stops it. The 2.4 and 2.0 Theta 2. Regulators described metal debris generated while manufacturing the crankshaft being left in the crank's oil passages, which over time could be forced into the connecting rod oiling passages, restricting oil flow to the bearings, raising temperatures, and leading to premature rod bearing wear, failure, and a stall. Not debris floating in the sump. Debris inside the crankshaft itself, in the drillings that feed each rod bearing, waiting. The root cause is described as inadequate deburring of the crankshaft oil holes during machining. The first recall in September 2015 covered 470,000 Sonatas, and it kept expanding for the better part of a decade. And because a rod bearing that lets go can put a rod through the side of the block, this one added a hazard the other two mostly didn't. In a smaller number of cases, oil leaking onto a hot exhaust caused a fire, even with the car parked and not running. You're still with me, so here's the one I'd have missed if I hadn't gone looking. In 2025, Hyundai recalled 2025 and 2026 Santa Fe and Tucson models with 2.5-liter engines because the connecting rod retention bolts had been installed with low torque, and the remedy was replacement of the engine. No debris, no grinding error. A bolt that didn't get tightened enough. Underclamped big ends hammer the bearing under peak cylinder pressure, and a stretched bolt can fail without any knock beforehand. 3 companies. Debris in one, geometry in the second, clamp load in the third. Utterly different mistakes, identical outcomes, because all 3 engines were built with the same missing allowance for being slightly wrong. Right, that's the diagnosis. Before we get to what you can do about it, and before I show you the remedy that made me genuinely angry, If you want more of this kind of thing, plainly explained with the documents in front of us, subscribing is the whole ask. And stay with me for the part about your oil filter, because there's a number in it that most people have never been told, and it changes what you think that filter is for. Here's that number. Your oil filter is not protecting your bearings from this. Engine wear is predominantly caused by particles in the 1 to 40 micron range, with the 5 to 20 micron band being the most damaging. Clearance-sized particles that act like liquid sandpaper as they recirculate. A typical full-flow filter is nowhere near that fine. One premium filter is quoted at 99% efficient at 20 microns and 94% at 10, and plenty of factory filters are considerably coarser. Worse, the rating game is largely theater. From a purely legal standpoint, if a filter traps one single piece of 30-micron debris, the manufacturer can state it filters at the 30-micron level. Then there's the valve nobody mentions. Every engine oil filter has a bypass valve, so the engine doesn't get starved as the filter loads up. That's correct engineering, and it also means that in the moment your filter is doing the most work. Cold start, thick oil, a filter halfway through its life. Some of your oil is going around it. Dirty oil beats no oil. But if you thought there was a barrier between the swarf and your crankshaft, there isn't. There's a suggestion. And this is where I have to be straight with you about the limits, because there's a lot of confident nonsense out there. Running a thicker oil will not fix a defective engine. It's the first thing everybody reaches for, and I understand why. More film, more margin, seems obvious. But the clearances were reduced to suit the thin oil, and going the wrong way on viscosity can reduce oil film thickness and let the crank and bearing contact in an engine designed around flow. If your engine has genuine wear and 100,000 miles on it, a step up in viscosity is a defensible conversation with someone who knows your specific engine. As a preventative on a new one under warranty, it's a good way to own the problem legally without solving it mechanically. Oil analysis is a real tool, and it is not a smoke alarm. Lead and copper rising together, especially with tin, is a specific signature that points to bearing overlay wear with high diagnostic confidence. If you run a fleet or you tow for a living, a sample every change is cheap insurance. But the honest caveat is that you have to sample often enough to catch the wear while the particles are still small enough for the spectrometer to see them. A bearing that goes from fine to destroyed between two oil changes will produce debris too big to register, and you'll get a clean report on an engine that's already dying. Clean sample, good news. Clean sample, not a guarantee. So what does work? 3 things, and they're all unglamorous. Change the first fill early. Not because the factory oil is bad, but because the first few thousand miles is when the engine sheds everything the wash station missed, and the sooner that's out of the sump, the fewer laps it does through your bearings. Toyota's approved interval on 0W20 vehicles is 10,000 miles or 12 months, with everything else on 5,000. And their own guidance drops that to 5,000 regardless of oil if you're towing, driving on dirt roads, doing repeated short trips in the cold, or idling extensively. Read that list. If you own a truck, you probably live on that list, and the 10,000-mile number on the windshield sticker was never yours. Cut your old filter open. A filter cutter is a cheap tool. It takes 5 minutes, and it's the closest thing you have to looking inside your own engine. Roll the pleats out in good light. Gray sludge is normal. Glitter is not. Do it every change and you build a baseline. And a baseline is what makes an abnormality visible. And take a knock seriously the first time, not the second. If you hear engine knocking or the vehicle stalls, the engine can seize at any time, which is a crash risk. That's not my caution. That's the language on the recall. A deep, rhythmic knock that rises with load is not a thing to drive across town on. Two more details that round the picture out. The engines got fixed quietly. Engines built with a redesigned number 1 main bearing from July 2024 onward. And all replacement engines sit outside the Toyota recall population, though the company says it continues to monitor them. A redesigned bearing for a debris problem. You can hold both ideas, that debris was the trigger and that the part was changed anyway, and I'd suggest you hold both, because that's what the evidence supports. The physical scale of putting it right is worth understanding too, because it explains the decision I'm about to walk you through. More than 270,000 trucks and SUVs with that engine have been recalled. Each engine replacement takes somewhere between 13 and 21 hours, so dealerships have to juggle workflow just to keep bays free for ordinary warranty work. Over 70,000 engines have been replaced so far. That is a colossal, expensive undertaking, and I'll give credit where it's due. Replacing 70,000 engines is not a company running away from a problem. Which brings us to the part where somebody is coming for you. When a manufacturer builds a defective engine, they owe you a good engine. That's the deal. And what several of them have worked out is that the deal has a loophole. Because the obligation isn't really to give you a good engine, it's to give you an engine that can't be proven bad. Those are different things. The difference is worth billions of dollars. And it comes directly out of your pocket as risk you didn't agree to carry. Look at what Hyundai's remedy actually was for the crankshaft debris defect. Not an inspection of the crankshaft. The remedy was an engine noise inspection, which consisted of moving your vehicle to a quiet place and positioning a mobile tablet near the steering wheel to assess the engine sound. And an algorithm, unexplained in the repair instructions, determined whether your vehicle passed or failed. Read that as an owner and not as a headline. Your engine may have metal in its oil passages. The company knows it. And what stands between you and a seized rod on an interstate on-ramp is a tablet on a dashboard and a pass-fail algorithm the repair documentation does not explain. Not to you, not to your technician, not to the regulator reading it. Nobody has ever published how that thing decided. I've looked, I could not find it. And I've stopped assuming that's an oversight. Then came the longer-term remedy, which was software. A knock sensor detection system. Software that watches engine sensors for early signs of bearing wear and alerts the driver before a full failure. In the settlement warranty owners were promised, eligibility often required installing that updated software, and if the software flagged a problem, dealers were then authorized to inspect and, if necessary, replace the engine. Understand the shape of that. You have a hardware defect, metal, in a passage, machined in. What you were handed is a listening device, and your extended coverage is conditional on you accepting it. The software does not remove the debris. It does not fix the bearing. It waits, on your dime, on your commute, with your family in the vehicle, for the failure the company already knows may be in there, and its function is to notice that failure slightly before you do. Now watch Toyota walk the same path. The fix used to be a new engine. That was the remedy for the first recall. Then, faced with building an extra 270,000 engines, the company developed a test. Using inspection software, dealers evaluate the number one main bearing and collect available vehicle drive data to confirm its condition, and only if the software cannot confirm the bearing is free from abnormal wear does the engine get replaced. How does it see inside a sealed engine? A company spokesperson explained that fundamentally, the inspection uses the resonant frequency of the front of the crankshaft to assess the condition of that bearing. Is that bad engineering? No. It's clever engineering. And honestly, replacing 100% of engines to catch a small failing fraction is wasteful and slow, and leaves people driving unfixed trucks for a year in a queue. There's a real argument for it. But notice which way the uncertainty flows. Remember Honda's number, roughly 1% estimated to actually carry the defect. Under a replace everything remedy, the company eats the cost of the 99. Under a test and triage remedy, you carry the risk that the test was wrong about yours. The engineering changed, the economics changed, and the person whose position quietly got worse without ever being consulted is you, sitting in the driver's seat, holding a piece of paper that says you passed. They can do this because a defect that hasn't killed your engine yet is legally indistinguishable from no defect at all. That's the sentence. Learn it, and it stops working on you. When a remedy listens instead of repairs, you have not been fixed. You've been monitored, and the monitoring is cheaper than the fixing. And that is the entire reason it exists. For what it's worth, when Hyundai and Kia were found to have moved too slowly on this, the consequences were real. Consent orders totaling 210 million over untimely recalls of more than 1.6 million vehicles and inaccurate reporting to the regulator. The government paid a whistleblower more than 24 million, its first ever such award, and the maximum the law allows. Somebody on the inside had to blow the thing open to get there. Here's the part I keep coming back to. And it isn't really about cars. Every good design has slack in it. The old 1,000th per inch clearance wasn't chosen because it was optimal on a test bench. It was chosen because it worked when the crank was a bit off, when the shop was a bit dusty, when the oil was a bit old, and the owner was a bit late. That slack is an engineer being generous to a stranger. It's someone who will never meet you deciding in advance that the world is imperfect and building room for it. Margin like that is invisible when it's working. Nobody's ever thanked an engineer for the failure that didn't happen, which makes it the easiest thing in the world to spend, because you can convert it into a measurable gain, a fraction of a mile per gallon, a compliance number, a line on a chart. And the cost doesn't show up for 6 years, in somebody else's driveway, on somebody else's credit card. I don't think anyone set out to build a fragile engine. I think 1,000 reasonable people each spent a little bit of somebody else's margin, and none of them ever saw the pile. And the reason old iron feels good to work on isn't nostalgia. It's that you can feel the generosity in it. The extra thickness, the fastener stronger than it needs to be, the room to be a little bit wrong. Building in slack is a moral position dressed up as engineering. It's how you take care of people you'll never meet. Right. Here's what to actually do, in order. Check your VIN, not a forum, not a video, not what a guy at the counter told you. Run it through the federal recall database yourself and run it again in 6 months, because these populations keep expanding. The newest Toyota campaign expands the two before it, and that pattern is the rule. If you're in Canada, Transport Canada runs mirror campaigns, and the affected engines and failure mode are identical. If you own an affected Theta 2, install the software even if it annoys you. because the lifetime engine warranty from the settlement remains available to owners of covered vehicles who install the free NOx sensor update, and a warranty you find irritating is still worth more than a principal. Keep every oil change receipt in one folder. Claims turn on maintenance records, and that folder is the difference between a covered engine and a $10,000 argument. Have your interval if you tow, idle, run short trips, or live somewhere hot. And cut every filter open. Build the baseline. Here's the procedure I'd run rather than a rule of thumb, because whether one of these vehicles is a bad buy depends on numbers that are yours and not mine. Get 3 figures. 1. What a replacement engine costs installed on this specific vehicle from a dealer in writing. On a mainstream crossover that's north of $10,000 with 12 to 18 hours of labor, and on a current full-size truck, you're looking at figures that can run past $15,000. 2. How much factory powertrain coverage is genuinely left in months and miles, verified by the manufacturer's own VIN lookup and not the seller's memory. 3. Whether this exact engine, in this exact production window, sits inside a recall, an open investigation, or neither. Then the decision makes itself. Coverage comfortably outlasts your ownership plan, and the engine is remedied or outside the population. Buy it and change the oil early. Coverage runs out before you'd sell, and there's an open investigation with no remedy announced. You're not buying a vehicle, you're buying a lottery ticket where the losing prize is the cost of a decent used car. And if the engine's already been replaced under recall with the updated part, that's frequently the best version of that vehicle on the lot, which is the sort of inversion nobody tells you about. Run those 3 numbers on any engine, any brand, any decade. It's not a Toyota procedure or a Hyundai procedure. It's how you buy machinery when the company that made it is no longer the only source of truth about it. This weekend, do the filter. Drain it warm, cut it open, roll the pleats out flat under a decent light, and look. Most of you will see gray and nothing more. And you'll go inside and forget about it. And that's the correct outcome. But you'll have looked. You'll have gone from a person who's told what condition their engine is in to a person who checks. That's not a small change. That's the whole thing, actually. Now, I want to hear from the people who've lived this. If your engine let go, tell me the mileage. Tell me what it was doing when it happened, and tell me what the bill was or what the dealer said. And if you're on the other side of it, if you've got one of these engines sitting at 180,000 miles doing exactly nothing wrong, say that too. And say what your oil habits have been, because that's the data that never makes the news. And it's the data I trust most. I already know some of you are going to come at me with the argument that this is all neglect, that people skip oil changes and blame the manufacturer. And honestly, you're not wrong that it happens. Bring it. Bring the mileage and the maintenance history with it. And I'll read every word, because the ones who disagree with evidence are the reason this channel gets things right more often than it gets them wrong. If you got something out of this, subscribing is what keeps it going. And there's a thread here I deliberately didn't pull today. Those 400-odd Honda rod bearing failures that were investigated and found to be outside the known defect. The ones where the explanation everybody accepted turned out not to apply. I don't have the bottom of that yet. I'm working on it, and when I do, it'll be here. Until then, check your VIN, cut your filter, and don't drive on a knock.